Recording in progress.
Okay, so we did question. So we did question. We did question 3 of the NZMO1. Yeah, which was this question. Do you remember this question?
Wait, did we do it last week?
So what we did was, so I did it on the Monday of the Tuesday class. Yeah, but I didn't exactly do it. I just went through Andy's solution. Okay. So I'll put that video up and I'll tell you how to watch the replays on the videos at the end, okay? But what Andy's solution involved was trigonometry, and a lot of people might not be comfortable enough with trigonometry to fully appreciate the solution. Okay? So what I want to show you right now is a very direct solution to this algebra question with the algebra that's in front of you. Okay? So okay, how is trigonometry related? Well, basically the question says to solve these two equations simultaneously, right? Okay. And I guess trigonometry is related because this is this here is the equation of a circle. I don't know, you guys know the equation of a circle?
No.
So equation of a circle is a x squared plus y squared represents the distance between a point y and the xy and the origin. So that's Pythagoras, okay? So the distance squared equals 2. So that means the distance from the origin is fixed. So it's a circle of radius √2, okay? And so when you have a circle, you can parameterize the x and y using sine and cosine. Okay. So another way of saying that, I guess, is if you let the hypotenuse be the radius of the circle, then like the y and the x are sort of like the adjacent and opposite sides to the angle that the radius makes with the x-axis. Okay. And so you get some yeah. So you can watch that video for the trig solution, and I'm going to show you a direct solution here. So, it is unfortunate. So one thing that I always regret when I show people solutions is if they hadn't had a chance to try the problem themselves. Okay, but in principle, these problems were out since the second week of holidays.
Wouldn't the answer just be x is equal to 1, y is equal to 1?
Okay, so we have to prove it. Okay.
Oh.
So Rihanna noticed that if you sub in x equals 1 and y equals 1, yeah, both equations are satisfied, yeah. So that means x11 is a solution, yeah. Yeah. The question is, are there any other solutions? Okay. Okay. So, and I want to show you can solve this problem using some fairly basic instincts in algebra. Okay, and the stuff you don't know, we're actually gonna you probably do know everything though. So, okay, so the first step, we look at equation 2, right? And we do the most obvious thing there is, which is clear the denominators. Okay. So we times everything by 2 minus y, 2 minus x. Yeah? Then you get this, yeah? Okay. And then we notice that, so this is just basic algebra technique. Then we collect like terms, right? Well, so we expanded these brackets.
Yep.
And we expanded these brackets in order to collect like terms, right? One simplification is that because we know x squared plus y squared equals 2, right? Because of this, yeah? We can substitute this as 2, yeah? Okay. And then after we make this 2, this becomes 4, yeah? Okay. And this 4 cancels with one of these 4s, you know? So this becomes a 2 now, see?
Mhm.
Okay, then everything else I've left unchanged.
So why has it become 2? Doesn't it completely cancel out if it's 4?
It's 8. It's 2 times 4 is 8, yeah?
Oh.
And then there's 4 here. So now it's 2 times 2 is 4, yeah? Okay. So we're good with here, right?
Yep.
Just slow me down. This always goes a little bit faster than I'd like because I actually wrote all the things out already. Usually the writing slows me down enough that it can't be going too fast, yeah? Because we're up to here, yeah? It's good to see the students improving a lot in this class. I'm pretty happy with that. Okay, so then we just put the x cubed plus y cubed on the same side. It's all equal to 0, yeah? Okay. Okay, so when you got an equation equal to 0, you tend to want to factorize anyway, okay? And the reason is because if two things times together equals 0, then one of them has to be 0. So it simplifies the problem. But here we're factorizing.
X cubed plus y cubed.
Yeah, maybe for another reason, okay? So you guys know how to do a sum of two cubes?
Yeah.
So who's heard of a sum of two cubes? Who has not heard of a sum of two cubes? Maybe a yes or no in the chat. Sum of two cubes. Okay. Yeah, so we'll come back to this, but a sum of two cubes is like this. X cubed plus y cubed equals x plus y times x squared minus xy plus y squared. So to verify, you just need to expand the right-hand side. But you can always factorize a sum of two cubes like this. Yeah, so this is a good example because our theory basically is the generalizations of these examples. So it doesn't really make sense to factorize it. I mean, on its own, because I mean, what you might get an x plus y and you have an x plus y, but there's other stuff there as well, right? But it does make sense for two reasons. Okay, so it does lead to further factorizations. Okay, but the most obvious reason is that it gives you a reduction. Okay, the hell. Okay, it gives you a reduction. See, because we know x squared plus y squared equals 2, right? You see that? So that immediately gives you this reduction. So you get, so this now is equal to 2 plus xy, right? Or 2, well, this should be a minus. Oh, that's weird. How come I wrote a plus? I wrote a plus and then I fixed it up later. Okay, this should be a minus, okay? So what you get is this is 2 minus xy, yeah? What does that sound? Is that me?
Yes.
I'm getting Discord pinged without any pings showing up.
Doesn't sound like this.
Oh, it's like the Facebook ping. How do I remove these annoying things? It's this thing. Okay, let me just close that. Okay. So you got 2 minus xy, yeah?
Yes.
Okay. So it might have gotten a bit messy. Maybe we just continue from here. I'll write this again, okay? We got 0 equals 4 minus 4x minus 4y plus 2xy plus x plus y 2 minus xy. Yeah? Okay, let's just start from here, okay? Okay, I've kind of done a lot of the work already here, right? What else can I do?
You know, like factorize the fours.
Um,
You have a 4 in front of it.
Factorize the 4s, yeah, but then I can't get a 4 here, right? So maybe you have to be more select. Expand the bracket. Actually, that's not a bad idea, yeah. Let's expand the bracket. So expanding the bracket would usually just undo the factorization and do nothing, right?
Yeah.
But we applied the relation in between. So this is called conjugation, what we're doing. So we're doing something in between, and then undoing the first thing, you know? Okay, good instincts. You know how to expand this bracket?
X plus 2y minus x squared 5 minus xy squared.
Minus x squared y minus xy squared. Yeah? Yeah. So Martin, sometimes a good question can also slow down the discussion, yeah? You can ask a question.
I know how that works, so.
Huh?
I know how that works.
Yeah?
Yeah.
Yeah, I mean, it's good. Sometimes, like, the whole point of this interaction, right, is that, like, we adjust to each other, you know what I mean? Like, if I'm going too slow, you can be like, oh yeah, I get that. Like, and I'll be like, oh, you get that. I can go faster. You know what I mean? Like, oh wait, no, I don't quite get that. I go slower. You know what I'm saying?
Yeah.
So that's what you can't get out of the recordings, yeah. But you can sort of rewind and fast forward in the recordings. It's just a little bit different. Okay. Okay. Now what now?
Get rid of the
Like terms, yeah. So the whole point of doing that really was the 2x plus y, yeah. So 0 equals 4 minus 2x minus 2y plus 2xy minus x squared y minus xy squared, right? It looks nicer already, yeah? Okay, so the next one is a bit harder to see what to do.
x and y from the last two terms. I don't know.
You want to factor in x, y? Is
Yeah?
that what you want to do?
I don't know.
Okay, I'll try that. So you notice there's a factor of. Oh, so by the way, if you're trying to factorize this and it has 6 terms, right?
Mm-hmm.
So this 6 terms, it could be like, it could be 2 times 3 terms, right? Or it could be like 2 times 4 terms where like 2 of the terms cancel or something. Or it could be like, but it can't be like 3 times 3 terms unless sort of the terms don't quite cancel properly. Okay, anyway, let me just write down this suggestion. So you're trying to factor in xy from what? From the last two?
Three terms.
The last 3 terms. Okay, look at that. So this is.
And then you factor out the 2 from the first 3 terms.
Oh my gosh.
And then it's magic.
Yeah, so I don't need to praise this, right? This speaks for itself, you see. The awesomeness of this is apparent. And now you have a common factor, right?
Yeah.
So 0 equals 2 plus xy, yeah, times 2 minus x minus y, okay?
Mm.
That makes sense?
Mm-hmm.
Yeah. It's weird, I must have had a minus xy somewhere before. Okay, so what do we do now? Okay, so this is standard kind of stuff. Whenever you have two things times together get 0, this is the whole point of factorizing. One of them has to be 0, right?
Yeah.
So it gives you more cases, but each case is much easier. Yeah. So you're basically solving two equations. You're solving x plus xy plus 2 equals 0. Yeah. Or you're solving 2 minus x minus y equals 0. Okay.
So x plus y equals it.
Okay, x plus y equals to 2. And here you can write xy equals minus 2. Yeah. Okay, so I'll just keep going. I really wish people tried this, so I don't feel as guilty about telling the solutions. And of course, it's kind of weird. I always say I'm guilty about telling the solutions when in every other aspect of your life, no one ever feels guilty about telling you the solutions, right? They start with the solutions. Okay, but the thing is, I'm aware of sort of what it takes to make a mathematician. So, okay, so the next thing is a very common trick. Okay, so do you guys know this? This, right?
Yeah.
And obviously, if it's x minus y, it's like this, yeah? So the next little trick is just to exploit these things, okay? So for example, you have like x squared plus y squared equals 2, right?
Yeah.
Isn't it equal to 4?
No. We're given it's equal to 2.
That's the very
Oh, yeah.
This one, yeah? And also, it's not equal to 4 because remember there's a 2xy here, remember?
Oh.
Okay. This squared is not just a separate, you can't square them separately, you know? So how does this work?
When you could square it, and then the 2xy you could get from that the left thing, and then put it in, if that makes sense.
Okay. Yeah, so let's see, what does this mean? So, for example, I square it like you say, right? And then right, what did Finn do? So for example, I could square, yeah, like that, there can be any numbers, real numbers. So if I square that, I get x squared plus 2xy plus y squared equals 4, yeah? And then I have x squared plus y squared equals 2, right? So then I get 2xy equals 2, you know?
And then xy equals 1.
xy equals 1. Okay. So maybe this is more familiar territory now, okay? Sometimes you just gotta get it to familiar territory. Right. So what's the familiar territory? Have you guys heard of quadratic equations?
Yeah.
Huh? Have you heard of quadratic equations? So quadratic equations is kind of like like those questions like if you know the perimeter is this and the area is this, then what are the side lengths or something, right? So there's a classic quadratic situation where you know the sum of two things and you know the product of two things. Yeah. So there's lots of ways to turn this into a quadratic. So actually the shortest way to turn this into a quadratic, I'll show you the short way and the long way, okay? So the shortest way to turn this into quadratic is if you know the quadratic has two solutions and the sum is 2 and the product is 1, yeah, then the quadratic is basically like this. I'll use z to not be too confusing, or maybe be extra confusing. So z squared minus the sum. Actually, the z is too confusing. I'll use w. So w squared minus the sum of the roots, which is 2, plus the product of the roots, which is 1. Yeah. Okay. Or maybe a less confusing way of doing that is, okay, obviously x and y are not 0, right? Because they can't times 1. So I can write y equals 1 on x, yeah? From this, yeah? And then I sub y as 1 on x over here. So x plus 1 on x equals 2, right? And I times everything by x. I got x squared plus 1 equals 2x. X squared minus 2x plus 1 equals 0. Yeah?
Oh, yeah.
So these are the same, right? So, and you notice here that x minus is a perfect square, right?
Yeah.
That means x equals 1. So x equals 1 and then y equals 1 as well. Yeah. Okay, so this produces x equals 1 and y equals 1. Okay. Okay, so maybe you guys can do a bit more of this side. Is anyone interested in typing this question up? Because there are some interesting things to learn here. Okay, how do we do this?
Can you get paper?
Yes, do get some paper. Yes, I'll let you guys do this one. I won't spoil all the fun. No, you got anything that's basically blank side up? Yeah. Yeah. Fine.
Yeah, thank you.
Yes.
Got one, son.
Oh. Who's gone?
Okay, so we saw the one in the green.
Yeah, the left one, yeah. Okay, while you guys are doing that, I'm gonna upload the video.
Hmm. Uh,
Monday the 25th. This is a morning. Oh, maybe we did on Tuesday.
mm,
I'll turn the volume down so it won't
we can
distract.
try solution. So I come to a solution, but I don't know. I'm really unsure about it.
Oh, which means it's not a solution.
Yeah.
It's, but it could be the beginning of something good. Like this was.
So I can roll the lines a bit more.
Yes.
Is there even a solution for that one?
Maybe not, but. Okay, is that enough time?
Okay, so I'm more sure of my solution now.
Okay, so what did you do? So we're basically doing xy equals minus 2 and x squared plus y squared equals 2, right?
I used x plus y equals 2 from earlier in the other equation.
No, these are separate. You can't combine them.
Oh,
It's or either this or that, not both. Yeah.
Okay, that's.
I mean, it could be both, but you don't know.
Yeah, because that's not like the same variables. So but they'll be the same.
Did you do this?
Yeah.
What'd you get?
I'm not sure what I did. Because I did it like this, right? I put them together and then I got a solution, but I don't know whether I did it right or wrong.
Oh no, this is good. So you add basically these together. Yeah.
Yeah.
And then this is minus 2, right? Okay. And you get this is x plus y squared. Yeah? Equals minus 2. Yeah?
Yeah.
So a square number cannot be negative. We don't have x plus y equals 2, okay? That's in the other case.
Seems not fun.
So we're considering each case separately. So you have x plus y equals 2 in that case, which we dealt with before. And then we have xy equals minus 2 in this case, okay? The x plus y equals 2 gives you that xy equals 1, which is already contradictory. Xy equals minus 2 is one case, and x plus y equals 2 is the other case. So this has no solutions.
Oh.
Okay. Who's interested in typing this up into the LaTeX? Any volunteers? So.
Wait, but what if you did x squared minus 2xy plus y squared?
You would get something x minus y equals the root of 6 plus or minus the square root of 6 or something.
Yeah.
Okay, so it'll take you longer before you figure out those no solutions.
Oh.
Okay, I think you definitely should write this up because that's your solution, yeah? So.
Unlucky.
Not unlucky.
You're right on my hand, I'm gonna forget.
So basically, I mean the whiteboard's on Discord, right?
Yeah, I'm gonna forget when I go home.
Okay.
Can you square root minus 2y squared? You can't do that, right?
Yes, there's no solution.
Okay.
Okay, so do you know how to do these equations? So you can do dollar sign, dollar sign, dollar sign, dollar sign.
Write fractions.
Like that.
It doesn't have to write fractions.
Oh, you don't have to write fractions because they're cleared right away. That's the first line.
Oh.
See, the first step is to get rid of the need to write fractions ever again.
But I typically put the question in and then answer it.
Was wondering what you meant by that message. What message? Okay, so Rihanna, this is your task. Should you choose to accept it?
Okay.
Basically, type these 4 lines with dollar signs, yeah?
Yep.
Or 5 lines, I guess. And then break up into 2 cases and type them both, yeah? Yes. Yes, dollar signs make maths. Okay, so that proves that the only solutions are one and like there's only one solution and it's 1, 1. Yeah. Like
Yeah.
out of all the points on the plane, only 1, 1 is a solution. Yeah. Okay, who understands what just happened? Let's have a poll.
What happened here?
Wait, someone's not voting.
Oh, okay. So you put this into here.
So someone not
This
voting, but not asking questions.
times 2. We get the 2xy, so that's times 2. And since you're adding this, you add. Yeah.
Oh wait, so you just like put you sub.
Yeah, you just take this and put it into that one.
You take this number and put it back.
Yeah, and multiply by 2, so you get the perfect square.
Don't need to multiply by -2 because then you get -x.
And then this will happen.
Alright, so one very good, one decent, one unclear. So remember I asked you about asking questions? You shouldn't leave the whole segment without asking a single question.
No.
Find the shape of neutral and anti-neutral.
No solution.
Alright. So who's unclear? What's the question? What don't you understand?
Is there any questions on?
It's now time for questions to be asked.
Yeah, so far I'm confident Rihanna understands this. Finn seems to understand this. What if x equals 4 and y equals 2? Well, I don't think those sum up to 2, right, when you square them.
Oh. Funky. Wait, what does xy equal again?
Either -2 or 1.
Oh yeah, it's true.
Yeah, then you can also try to find a shorter way to do it, now that you know it can be done, right? So that's sometimes why some solutions are very mysterious, yeah? You just delete all the steps that you came up with to solve it, that you didn't actually need. No, if you square them and add them up, they're not equal to 2, yeah?
Negative number squared is positive.
Okay.
Wait, so
Yeah.
in Rihanna's solution, she went from she put 2xy equals to -4 into x squared plus y squared equals 2. Are we allowed to do that without like changing it at all?
What do you
Like,
mean?
just put it in.
Oh no, you don't put it in because xy equals -2, right?
Yeah.
So when you put it, so putting it in is the same as putting -2 in, yeah?
-2 in what? Like.
So we have this is equal to 2, right?
Yeah.
And I want to put in xy here, right?
Yeah.
So when I put in xy here, I'm putting in -2, right?
Yeah.
So that's why the -4 is here, yeah? It makes up for this.
Oh.
You're adding the equations together.
Oh, wait. Oh, yeah, that's what we're doing. That's correct. Great idea, sir. Thank you.
And x squared plus y squared equals 2 is the question that was asked. It was like, what are the solutions of these two equations, yeah?
Oh.
So the original question was that. Solve these two simultaneously.
Oh, yes, that makes sense.
Does that make sense? Where this dialogue is rather. Okay, if no one's gonna say anything, I'm gonna move on.